the general form of the equation of plane is ax plus by plus cz equals to d. So say we have a plane like this, and there's a point in space, let's call it P, and we're interested to find the shortest distance from P to the plane. And suppose we have the eye is here, look from this direction, and you see something like the plane. There's a plane, and there's a point P, and this distance, which is the perpendicular line segment from P to the plane, let's call that D, and this is the shortest distance. And the formula to calculate this value of D is equivalent to the absolute of A times, well, the point P, say we know the coordinates of P, of course, and let's call that x1, y1, and z1. So the formula to calculate this distance D will be then A times x1 plus B times y1 plus C times z1 and minus D, and the whole thing divided by the square root of the sum of A squared, B squared, and C squared. Suppose that we want to find the distance, the shortest distance from this point P to the plane given. That would be fairly easy. Just use the formula, and that would be D equivalent to the absolute of ax1. Now A is a coefficient of x, so A is 1. That would be 1, and x1 is 1. And plus b will be the coefficients of y1 is -3, and c is -1, and times 2, and minus d, and in this case d is 2, so there will be minus 2, and holding divided by this 1 square plus 1 square plus a -1 square, and if you simplify this, you will get in the end this will be the square root of 3 or third 3, and the numerator will be 6. Now suppose there's a different situations, so we look at one example, describe a way to tackle different situations or finding a distance between two parallel planes. Suppose we have two planes which are parallel as like this, and so what we want to know is what's the shortest distance between these two planes, and that is something like this. This value D, we want to find this, is perpendicular to both planes, of course. And to do that, we use a very nice idea. First, we would try to find a point on plane 1, okay, and so we'll get the point P. And so like before, since we know the plane, the point P, we can then find this distance easily by using the distance from a point to a plane formula. Now, take for example this problem here. Suppose the equation of two planes given, plane 1 and the second plane. And so what we're going to do is to work with the first plane and to determine a point which this plane 1 passes through. Now the idea is very simple. We set up the possible values of x, y, and z, which sums up to 4. So I can say for plane 1, I set by choice I set x equals 1, y equals to 1. And so if I substitute these two values into the equation of plane 1, then we get 1 plus 1 plus 2 times something equal to 4. Of course, this is 1, this is 1. The value here must be 1, so that I'll get 1 plus 1 plus 2 times 1. And it sums up to, together they sum up to 4, so it has to be 1 here. And therefore, z will be 1, 2. In other words, the point P 1, 1, 1 is on plane 1. You can check that is the case. So the shortest distance from the point P here, which is on plane 1, to the plane 2 will be like this. First I'm going to rewrite the equation of plane 2 to look like this. So I'm going to rearrange so I get negative 11 here. And then the point P is 1, 1, 1. So the shortest distance would be this, 2 times 1 plus 2 times 1 plus 4 times 1 minus negative 11, and the whole thing divided by 2 square plus 2 square plus 4 square. And if we simplify this, in the end we'll get 19 over 3rd 24.